So hopefully you've come ready. So you can ask questions. If you haven't corrected test 1 yet, can you still turn it in? Of course you can. Are you going to get as many points back as if it was on time? No. But if you get enough of the corrections right, you'll get something back, right? So might as well do it, right? To me, if there's some homework you haven't done versus tests you haven't corrected, you might want to correct the tests first, because that helps you study and it directly increases your grade more than homework would do, right? Now, if there are entire chapters you haven't done homework in, anybody? You're going to want to do some. Maybe with an eye towards, all right, these are just going to be nothing. I'm just going to do a few out of each section. And not like number 2 and number 3. Because that's not going to be representative of what I would probably give you on the test. Those are the little baby, get ready, here it comes, right? Is everybody with me on this? I mean, because one thing as a student is, how do I study? What's important to do? To me, it would be checklist, test corrections, practice final, and then any homework you haven't done, do some out of those sections. Because it's all about practice, right? Do not, I've said this before, but don't do like number 4 on the practice final 5 times. It's not doing anything for you, right? So that's a silly way to study.
Just to make sure, we still have final on Monday the 6th, right?
Say again?
We still have final on Monday the 6th.
Yes. So, how often will we be in this room next week? None. Good. Beautiful. I love it. Right? What time does the final start on Monday?
9:25.
This is June 6th. 9:25. I love it. So if you get here at 9 on the regular time, beautiful. My other class, their final starts an hour earlier than the class normally starts. I'm going to have people that come at 12:30, and I'm going to tell them, you've chosen to get 1 hour for your final. So you guys, it's good. It's after we normally start. So, does anyone have...
You come early, you start our final early?
No.
Does that mean the final's going toward like 11:30 then? It's 2 hours?
Yeah, it's 2 hours. So it's 9:25 to 11:25. Yeah. Thankfully, we now have a 10-minute cushion. It used to be the final would stop at 11:30 and the next final would start at 11:30. Right? So the next teacher would be out there and they open the door, hey, and I'm like, get out of here. Money, my Cleveland.
For me, I have this final finishing, and then immediately after that, the history final.
At least you got that 10 minutes, man. You can, right?
It starts at 11:25.
That's illegal.
That's my high school starting time.
Oh, you're high school. Right, that shit I can't do anything. Good luck. All right, guys. So we got today and we have Friday. So I'm gonna kind of open it up to any general questions. I kind of, I'll see what happens. I might start to get us to go straight through this, but I want to address any specific questions. So sometimes it's better to go backwards in time, right? More recent stuff. I know a couple of you guys have started Section 8.1. Some of you guys have turned it in, which is awesome. But you'll find out 8.1 is not bad relative to some other stuff we've done. Average value of a function, so just kind of working backwards, right? I don't see anybody really raising their hand with questions. Average value of a function, what does it add on top of just normal calculus stuff, right? If I want to know the average value given f of x, and I want to know the average value on some interval.
You just take f of x and you integrate it.
Yeah, add up all the values.
And then you multiply it by 1 over v minus x.
Yeah, and then divide by how many there are, right? And now, it doesn't quite match up with what I just said, that's why I put quotes around it. It almost does, so it kind of feels like an average of a list of numbers. Add them all up, divide by how many are. What makes more sense is smushing it into a rectangle, right? And that's how I kind of started it off. Whatever it looks like, you can smoosh it into a rectangle, which is basically what this does. Okay, maybe? Yes?
Could you go over it? What's the differentiation?
Yeah, okay. So before we do implicit, let's do this. What would this be?
The chain rule.
Chain rule, I like it. So let me rewrite this like this, right? So how does that work?
1/2 created squared minus 7x times the derivative. Or, negative 1x times the derivative.
6x minus 7.
Right, whereas this is d this dx, right? Okay, I like it. So, is that cool? That's chain rule stuff. Does it really matter what I put in here? Would it change fundamentally what we just did? It would change the little details inside, but would it change what we did? We took the 1/2 down and went to a negative 1/2. This I wrote again, and I did its derivative. Sine x. Would I do anything different? No. Right? So if I had sine x inside, what would its derivative be?
1/2 sine to the negative 1/2 times cosine.
Yeah, let me write it like this. Right? Okay, so what implicit does is it says, let me capture that idea. So if I have, if I have y to the 1/2 equals x, right? And I want to do this implicitly. It's something to the 1/2 on that side, right? So so I want to find dy dx. Let me make sure we understand. So I'll do this side. Okay. So of course, what do I do to both sides? If I want to figure out dy dx, I'll take d by dx of both sides. And of course, dx is 1. Bam. Or the derivative of x is 1. Is everybody cool? Right. So how does this work? Well, we know how it works no matter what function. So do I know what function is in the 1/2 power? Did they tell me what y is? No. Good me either. But how does it work? How does it always work? If it's something to the 1/2, something to the 1/2, what happens? 1/2 comes down in front of stuff to the
Negative 1/2.
times y prime, or dy dx, right? Do you guys understand? That's all implicit is, oh shit, they didn't tell me what the function is. Who cares? I can still apply the rules, right? If the inside is more than just x, what rule comes into play? Chain. No matter what I make the function. So let me just say it's some function I didn't tell you what it is. That's all implicit is. I really want you guys to understand. Now, all right, so let's get into the specifics. How do I go from here? What do I want to solve for? I'm trying to find dy dx, which is this guy. So I just multiply. Do you guys understand how this is on the bottom too?
Yes.
So couldn't I just multiply by 2 and by y to the 1/2? Okay. So this is interesting. This derivative only cares about the y piece of any coordinate on the function. Very freaky. You guys see that? And again, that's a side note. Right? So if I want to know the derivative at 4, 2, right? If I put a 4 in y, don't I get a 2 for x? So if I want to know that derivative, what do I put in here? If I want to know the derivative at 2 comma 4, I put a 4 in here. It just wants the y piece, right? It doesn't care what the x piece is. And again, that's just a side note, right? All right, one extra thing on this. And then we'll do a little more complicated problem, and then we'll move on to another idea. Because this is pretty straightforward. Can I solve this first thing for what?
For
Can I I solve this for y?
Square both sides.
Second, sorry? Yeah, square both sides. Okay, y equals x squared. Is that cool? Right? So I could have done that in the beginning. Can I always do that? Oh, hell no. Right. But here I could. What's the derivative here? 2x. Is that this? Yes. So watch this. Y prime equals 2 times y to the 1/2. Well, what's y? X squared. What's the square root of x squared? Yeah, well, that's the So this kind of showed up, I think, in at least 1 or 2 problems in there. If you can solve for y, you should get the same answer if you didn't solve for y. But can you always solve for y? No, that's why implicit differentiation exists. Right? So if I just said find the derivative of this, find dy dx, I would hope somebody would solve for y. You don't have to do implicit here. So let's do one more where you have to. It's got a little more shit going on, right? Yeah, there we go. Equals. Let me make this y cosine x. Now, if anybody is able to solve that for y, please teach it. Okay. Now I kind of want to try, but can you tell why? I mean, can you immediately see why that's basically impossible? I mean, I could take the natural log and get that e done, but isn't that y buried inside a sine and a natural log now? Right? I can take inverse sine, but that isn't this y and this thing inside of an inverse sine. I mean, so it's kind of hard to get something out without putting something else in further. Does that make sense? Okay. So if I need to find dy dx, what do I do? Differentiate, right? Implicit. Yes. So what's the derivative sine? Holy shit. Derivative sine stuff is cosine stuff times derivative the inside. And look, I'm going to be nice to myself. I'm going to worry about that next. I'm not going to try to do too much at once. What's the derivative of e to the stuff? E to the stuff times? You're overthinking it. The derivative stuff, right? All right, you goos do this. You guys do that side. You goos do that too.
You just turned into the Swedish chef of puppets.
Sure, just for a moment. I've got the door in my head. What do you have to use here, of course? Product rule. So it's the derivative of y. Y prime. Plus, leave y alone. What's the derivative of cosine? Negative sign. 11. And again, when I'm doing this guy, I don't care about those. I think a lot of students, you sort of try to keep the whole thing in your head. And this might not be true for everybody, but when I'm looking at this guy, I only care about him. Nothing else matters. And that derivative is easy as shit, right? Derivative of that is just the product rule. Okay. So let's see what I got. I got cosine xy times, what happens here? What do I have to use there? Product rule. Derivative of x is 1 times y plus x times the derivative of y. Okay. Oh my gosh. This is where people start to feel a little overwhelmed. And again, I don't have to carry this whole thing in my head. What do I worry about right now? What's the only thing I'm worried about on the next step? What am I trying to solve for? Y prime. Do you see anywhere when I'm trying to solve an equation, what's the kind of the first level thing I look for? Distribution, right? So can't I distribute this? And now, what do I want to do? Second,
Get all the y primes to one side.
get all the y prime stuff to one side, just like I always do. What do you do in algebra trying to solve for x? Don't you get all the x shit to one side, all the stuff without x on the other side? Same thing. I want to get y prime. What y prime piece is in the wrong place?
Negative y prime equal y and then x y prime.
Okay, I like it. And to be honest, I like what you're doing. If I brought this over and subtracted this, that side would all be negative. So we could alleviate that problem. You guys understand what's happening? So I could move these two things over here. You don't have to. I could have just moved this guy over here. Right? But then this guy has to move over there. It's all negative. It doesn't matter. It's the right answer. Who cares? So what would you have done? Tomas and I would have done that. You would have done what?
You made it all negative.
Okay, let's do that. So if I, is everybody with me? I'm going to subtract this, and I'm going to subtract this. Get my y prime thing over here, and get my not y prime thing over there. Okay, so then I got x y prime, cosine x y, minus y prime e to the y, minus, so there it is, y prime cosine x equals negative y sine x, right? Minus y cosine x. And again, this is just, writing a lot of stuff, right? This is where students kind of give up a little bit, but it's just writing a lot of stuff. Just do it. It's awesome. And then,
Wrap it out of y prime.
now listen, I just said writing a bunch of stuff. I'm going to do something smart. I'm just not going to write everything. If I think of y prime out, aren't I going to get y prime times x cosine e minus ey minus cosine, and then I just have to divide by this stuff, right? So it's going to be this side over x cosine minus e to the y minus cosine. Crazy shit. And then if I ask you what's the derivative, what's dy dx at pi, comma, whatever, you would just throw it in, right? Okay. Is that, I don't know if that helps. I mean, it's the main thing to understand is exactly the first thing I did. No matter what I put into 1/2 power, the process stays the same. So that's really all, it's a sign of stuff. So the derivative will be cosine stuff times derivative of stuff. I mean, the rules don't change. The rules cannot change.
Sometimes with implicit, we take the derivative with respect to y, right?
Yes.
So then, like, you would.
And do you guys remember I told you a shortcut? Isn't this dy dx?
Oh,
So if I want dx dy, don't I just flip? It's almost too good to believe. You're like, it can't be that. It's never that. Well, it is that. If I ask you for dx dy, just flip that. That's what I did. Because I was more used to doing dy dx, right? So then I would just figure dy dx out and then I would flip it. Yeah. If you want to.
You actually like literally flipped it.
Literally, yeah. So dx dy would be x cosine blah 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 over negative y sine blah blah. You just hopefully that makes sense, right? If 1/2 equals 1 over x, then x equals 2. Okay, I like it. All right. So that's implicit. Now we all completely understand that. Yay! It's real easy, obviously. I mean, look at all this. And then people look at this and they're like, yeah, I can't do that. Well, I can't do that either. I did this, bam. Then I did this, bam. Right? Several tiny problems.
Do you do a related rates problem?
Say again?
Can you do a related rates problem?
Sure.
Those are the word problems, right?
Those are what now?
The word problems?
That's one type of word problem, yes.
Okay.
What was the other kind of word problem?
I would like number 5. A paper cup which you would fill with my, is being filled with water.
Oh yeah, okay, let's do that. So what's the first thing you should do on that problem? Can you see all that? Well, that sucks a little bit. Sorry, people at home. So what is the very first thing I should do on number 5? Paper cup. Everybody's got to practice fine art. Think? No.
Nobody actually needs spare. Yeah, I do.
So number 5, that's the paper cup, shape of a cone. So what's the very first thing I should do? Sorry. You're all like, we don't read it. All right, good.
Going out or?
Scratch your chin. Come.
Going out.
Draw it. Yeah, beautiful. All right, so. Choo, chaba, chaba. Doesn't have to be beautiful. That's gross. Who cares? That's really gross, right? Yeah, you guys give me shit about it? Draw a circle. Conical cup. There. That's better. Somebody sat on my cup earlier, so I got a new cup. All right, height 10 centimeters. Radius 3 centimeters. Being filled with water at the rate of 2 cubic centimeters per second. So what variable do I have to introduce so that I can write that in notation? What is that to change up? Volume. So I got a volume of the cone. Well, we'll just call V volume. So then dV dt is 2. Yeah. Let me stop for a minute. This is the stuff you can immediately do for yourself. It's what I told you. You're just summarizing what's important. Is it important that it's made out of paper? No. Okay, so let me just draw the shape, grab the important stuff. Here's the thing that what's the last thing here? Water level. Have I got water level up there yet? No. So we'll make this Kool-Aid. We'll make this Kool-Aid because my cup is blue. There's the Kool-Aid level, right? What's this?
5 centimeters.
No. Because isn't it changing? It's only that for an instant. So I don't do my snapshot stuff till later. So the water level at any time, what is it?
X.
If you want to. Is it everybody wants X? Okay, fine. Not H. Yeah, whatever. All right, so X. And then what else do I need to know? The radius, right? So what do you want to call that? You want to call that W or something? For the silent W in front of the word radius?
I was gonna say, like, wouldn't that just, since it's a cone, wouldn't it be like proportional to x?
Oh yeah, so we're going to use proportionality here in a minute, but I don't know where you get the 3 times X.
Well, 3/10 x.
Oh, 3/10. Okay.
Yes.
So we're going to get there. But what do you want to call this right now?
W.
11. Okay.
What is W representing here? That's
The radius of the water.
Okay.
So basically, when I fill this thing up, the cone of water has a height and a radius of its own.
Yeah.
And it lives within the bigger thing. We see this all the time, right? We have this big shape, with certain known, but then I'm filling it up or something, or I'm draining it. So the actual stuff I'm draining or filling has its own shape. It has its own measurements. And they're changing over time, so they have to be variables. So what's the volume of the water? Does anyone remember that? I would give you this probably, but you should by this point, maybe. Yes, 1/3 is a good start. 1/3. There's a pi in there.
Our W's.
Yeah, W squared. X. I like it. So in general, it's 1/3 pi r squared h. Stop for a minute. Real quick, you guys remember how a cylinder was pi r squared h? Because it was pi r squared for the area, and it was repeated h times. So when I cut a cone out, I cut 1/3 of the cylinder out as a cone. That's why it's 1/3 of what a cylinder would be. Okay. Okay. So like Tomas said, kind of implicitly, there's too many variables here, right? So the relationship, this is an easy relationship. A lot of the homework problems were not quite as easy, but a lot of them came down to similar somethings, right? So here I've got similar triangles, right? So what kind of proportion can I set up? Okay, so x to w, water to water equals, good, 10 to 3, cup to cup. And what are we interested in? Now fast forward, I was writing, when the water is 5 centimeters deep. So which variable do we want to keep? Because I want to be able to plug 5 in. So then which variable do I want to solve this for? W. So that's where it almost got 3/10 x, right? If you multiply, divide by 10, you get 3/10 x. I like it. So this should feel familiar. Draw the picture. Summarize what you're told. You have to come up with your own variables, right? Write what they tell you in symbols, right? And what did I really ask? Oh yeah. So what am I asking for in symbols?
Dx.
Good. Well, dx, dt. Yeah. Gotcha. Which again is why we don't care about W. Sorry, W. We don't give a shit about you. Get out. So now what do we do? I've got a formula that if I know W and X, I get the volume. Now, first thing I want to do is let's see. 9 divided by 3 is 3. Then I get x squared over 100 times x is x cubed over 100. Is that cool? So all I did was plug 3/10 x in for W, square it. 9 divided by 3 is 3. Pi, x squared over 100, x squared, and times another x, x cubed over 100. All right, some of you guys are, I can't read you at all. Draw like this. Is that all right? Draw a picture. Summarize shit. Write the equation. Right? Get rid of a variable. And now what am I going to do? Like, this is not useful to me, considering they told me this and they asked me this, and I don't see any of that in here. Say again?
Plug in 5, right?
I do eventually, so I know x is 5. But they're asking me, and they tell me this and this. So of course, what do I do to this equation to make it something that actually...
Or you solve for x and then
Say again?
you solve for x and take the derivative.
No. I could.
Yeah.
You don't have to. I just take the derivative, right? What's the derivative of volume? With respect to what? Time, because it's per second, right? So dv dt equals, the 3 pi over 100 is just a constant, yes? What's the derivative of x cubed? 3x squared. Times dx dt, good. Because x is isn't x changing over time? So it is a function of time, so it's gotta be. So related rates are sort of like the next evolutionary step of implicit differentiation. With implicit, I'm taking the derivative of y with respect to x, so that's where the implicit part. Here, I'm taking the derivative of everything with respect to t. So everything gets an extra piece attached, right? And now I can plug shit in, right? Now I don't care. So this is 2, this is 9 pi over 100 times 5 squared, and then I can just solve for dx dt, blah, blah, blah. This is where I lose interest. Now let's just do it. And of course, don't forget your units, because this is a physical problem. Right? I don't know if that helped anybody, but I mean, what's important with this problem is the steps. What was it about the problem that made me do and write what I did? Because I'm not going to give you the paper cup problem. I'm not. Okay. So let's see, that's related rates. That doesn't mean, when I check it off, you can still do another problem if you want to. I just want you to see what we still have to talk about if you want to. I mean, can anybody, the minute I do something that you're not sure why I did it, that's when you should ask, but was there any step here that didn't make sense why we did what we did? I mean, that's kind of a hard question to ask afterwards. You can think back and go, why the hell did he do that?
Why did we get the W?
This here?
Yeah.
So it came from this, which came from these triangles here, right? And again, the most important question is, why did you do this? I see where it came from. Why did we do this? Well, because this. Do I know anything about W?
That is 3 times x.
Well, not yet. I mean, at first. X is what they're asking me about and what they tell me something about. Did they tell me what W was? No. Do they ask me what dw dt is? No. So I just want W gone. I don't know anything about it, and I'm not being asked anything about it. Right? So then I say to myself, is there a relationship between these two variables? Well, yeah, there has to be, because the water has to live in the cone. So it's restricted by the dimensions of the cone. There should be some relationship between them. So this is an old ask me, tell me business, right? And maybe.
We're gonna do this and shells. This and shells.
Discs and shells, all right. Let's see. Do you want to do, let's see, wait, what was it? There was one I didn't do. Hold on. I gotta remember those. There's 2 I didn't do. Maybe I will do it when I redo the key. That'll be fine, Joseph.
So at the end, the answer is, do we get that, or do we just like write
It's
out?
8 over 9 pi, right? 8 over 9 pi centimeters per second. Is that right? This would be 25 over 100 is 1/4. Multiplied by 4 is 8. Divided by 9 pi. 8 over 9 pi centimeters per second.
Great. Sorry, I lost you, so it's
25 over 100 is 1/4.
Okay.
Multiplied by 4, it's 8. Divided by 9 pi is 8 over 9 pi.
Where are you getting
5 squared is 25.
Okay.
Over 100 is 1/4.
Yeah.
Multiply by 4, you get 8.
Or are you getting the multiplying by 4 and get 8? Oh.
Because you have to get rid of the freaking 4, right?
Right,
Okay.
yeah, I see it.
Trying to solve for dx dt. I like
Then
it.
how did 9 get on its own? Then how did 9 get on its own?
Okay, alright. Alright, I'll say this, Thomas. Take this, solve. That's all? Yeah, okay. Which one? Oh yeah, we haven't picked one yet. Let's see what happens if I try to make one up on my own. This should be exciting. Let's say I want to take the region bounded by x equals y squared minus this is going to be a little more exciting than it should. Y squared minus 1 and x equals y. This could get too interesting. Plus 3. That's going to work. Let's see. No. 2y plus 2. Let's see. Better work. Yeah. Let's see what happens. All right. Take the region bounded by those and rotate around. Let me think for a second. Rotate around. Let's do this first. Let me figure this out in a second. I'll tell you this in a second. Trying to make this up on the fly. So I will rotate around something. It almost doesn't matter right now what I'm going to rotate around, because it's the very first thing we do.
Let's grab.
Oh no, where did we?
Where they meet. Because that will help me draw it. So how do I figure out where they meet? Let's see if Jeff made something that works.
Is it the equal to each
Yeah, so I would take y squared minus 1, set it equal to 2y plus 2. What do I do from there?
3 over 2y plus 2 others.
So subtract the 2y, subtract the 2. This looks promising.
Y minus 3. Y plus 1.
Good, so at y equal 3 and negative 1, right? You guys with me? Is that, I mean, by this point, that step should be like locked in. That's one of the first things you care about, is if they don't give me an interval to work over, I need to figure out where they meet. Right? Even if they give me an interval, I need to figure out where they meet, just in case one changes to be on the top. So I got to do this almost always. What points are these?
8, 3, 0.
Yeah, 8, I like it, 3, and 0, yeah. Again, this is a little weird. I got the y pieces, I need to know the x pieces. Okay, I like it. How are we doing up here? So now the sketch doesn't have to be anything beautiful. So here's 0, negative 1. And then watch what I'm going to do. 8, 3. There it is. And this function does what? This function does what? Straight line. So I'm going to make this in blue. And this function, do you see how little work there is for that? If I find where they meet, what you got to do, so I know the region starts and stops, then I connect them with the shape they make. It's a line. No thought. What about this dude?
Sideways to
Parabola. And it's opening which way? There we go, I love it. I like it. It's like we're all doing the YMCA, just one letter. So let's see, I could do something like, screw it. It's gonna do like this, right? Something like that. It's gotta be -1, it's back 1 from where it would normally be, so. Something like that, it's probably not exactly, I don't care. doesn't matter. So let's say I want to go around, what are you going to do, Jeff? Around, x equals 8. Let's do that first, and then we'll do another one in a minute.
He's gonna use discs.
Why? What would discs require? Discs would need what? Integral dy, because x equals 8 is parallel to the y-axis. And of course, why do you say we use this then? Because my functions are functions of y, and if I try to solve for y, I'm going to get a plus or minus radical. I don't want this shit. Right? So again, this is all, hopefully I've made that really kind of clear over time. What considerations tell me which thing to do? Because that's the eternal problem in mathematics. Okay, I know how to do it, I just know when the hell to do it, right? Okay? So now that I've identified the method, I'm going to use discs. What do I need to figure out? First thing is it 1 radius or 2? How do I know it's 2 radii?
It's not bounded to the.
It's not hugging the axis of rotation, right? Let me put this little view in there. So if I start at the axis and I draw out, what's the first wall I hit? I hit this wall. How long is that?
No, 8 minus.
8 minus
2y plus
parentheses 2y plus 2. I got to subtract the whole thing. Is that cool? So it's always, what is it? What is it always?
Big.
Big minus small. I love it. Yeah. There's no guessing. There's no abstracting. There's no, no. Which one's bigger? Minus, which one's small, right? So I get the inner radius is 8, 6 minus 2y. Is that cool? What about the outer radius?
8 minus y squared minus 1.
Yeah, 8 minus,
Parentheses.
so I'll just go ahead and do this. So I get our outer is 9 minus y squared. Okay. And now you just set it up and do it, right? Thankfully, this is nobody's a trinomial, at least, right? That would be the worst thing for me to give you. And I'm going to try not to do problems that are like a lot of busy work in them, right? What would it be from to?
-1 to 3.
Yeah, because I care about what y is doing. It's going from -1 to 3 on the y. And then I've got my r outer squared minus my r inner squared. Are you guys cool with actually not doing that? I mean, could you, if I just gave you this problem just by itself, it started here, you should say, oh, good, yay. That should be everybody's reaction if I just gave you this. Maybe? Okay, good. So I'm not going to do that. All right, good. Now, let's do the same region, but let's rotate it around y equals 3. That sounds exciting. Yeah. Okay, so I'm going to take this guy away. Same region. So it's going to be -1, 3, 8, bam, bam. If you want to bring colored pencils, by the way, it's not a bad idea. Got a little skinnier when I got over there, but oh, exactly. So I want to go, now I want to rotate around y equals 3. So what disks would need what?
The x.
The x. And shells, of course, would then need the y. So it seems to make sense to use shells. Again, it really makes sense because obviously I want to do a shells problem to review it. But still, even if you didn't know that, shells definitely wins here.
is it like this?
Say again?
Right next to you it says this, right above here.
Yeah, why is it dy?
Yeah.
Can somebody remind me? This was x equals 8. What is that parallel to?
Oh.
So that's the cool thing about disks. Whatever the thing is parallel to, that is integral d that for disks. And shells, it's the opposite. That's why I said anything that disks doesn't work for, shells will, theoretically. As long as it's in function we can actually integrate, right? All right, so now what do I need to set up? How many radii will there be for shells? Always. I kind of made it a trick question. There's one radius. Always for shells. Why do I not care about inner and outer? Because the rectangle is only going to capture where something actually is, right? When I do disks, this guy includes empty space. That's why I have to subtract this guy out, because it's not actually there. It's like, damn it, I added shit that wasn't even there. Shells goes, I'm not going to add that shit in the first place. How will my rectangle be? Will it be standing up or laying down? You're doing this and saying standing up. It's got to be parallel to the what? What's it got to be parallel to? The axis. So it's going to be laying down. Is that cool? And how do I locate it then? Another one would be like here, right, for example. So I locate my rectangles by moving along the y-axis, which again is why that's dy. That's why it's dy, because that tells me how I locate my rectangles. For disks, this tells me how I locate my disks. Maybe. So I've got my rectangle. Let me kind of take him out so he doesn't freak us out. So in general, it's going to be, so you got to know this, so I should ask you, 2 pi, a to b, what goes inside? For shells. R? No. No? RH. In this case, it's dy. Right. So now I know exactly what I need to identify. Let's start with R. Where do I always start when I go to draw my radius? No. Start at the axis, wherever it is, and that could be small sometimes, right? So I start at the axis, and in this case I draw until I hit my rectangle. Now, how long is that?
3 minus 1.
3 minus y. So this radius, and again, I mean, if you're just sitting there going, I don't understand any of this shit, there's going to be one problem or two or maybe at the most, I'm just not going to do them, blah, blah, blah. It doesn't take that much thought to understand why this makes sense. The radius in a circle, how do we always draw the radius? Don't we start at the middle, draw out? Isn't this axis going to end up being the middle of this damn thing? So how do I draw a radius? Always start at the middle and draw out, right? I like it. And then I just have to do like you guys are saying, big minus small. Of course that tells me how long this thing is, right? If something went from 8 to 5, how long is it? 8 minus 5 is 3 feet or whatever the hell, right? So R is 3 minus y. What else do I need to know? The height. So that I just need the top and the bottom of the rectangle. So the height is going to be, what's the top of the rectangle? So I have to do this.
Squared minus 1.
Say again?
Y squared minus 1.
I love you guys so much. Okay,
Oh, no.
if you do this, what's the top? Isn't it the straight line, right? Okay, right? So this will be the straight line, 2y plus 2, minus the bottom, y squared minus 1. Let me do this over here, just get a little crazy here. The line minus the parabola. So the height will be 2y plus 3 minus y squared. Now I just throw stuff in. What's it go from to? Yeah, still negative 1 to 3 because I'm still going along the y-axis. So what I'm doing is I'm starting at A, I'm starting at negative 1, and I got a 0 rectangle there, and then I move here, and then I move here, and then I move here. Same way we always do, right? R is 3 minus y. H is 2y plus 3 minus y squared. And again, that's the boring step now, because now, and again, you have to be able to do it. It is new to us this semester, but if you saw that, you should be very happy. And if you're not, that's a problem. This should be equivalent to me asking you what, how to factor x squared minus 1 in pre-calculus. Right? You should see that and go, oh, holy crap, yeah, right? So you would just distribute, and then it's just a polynomial. Integrate, you can throw numbers in. Is that cool? And again, I don't mean to make you feel bad if you're not sure what to do. But does it matter where this integral came from? It doesn't matter. None of this matters now. Forget this. There. This is your whole world. That problem. Right? Just integrate that. Yeah. Okay. I don't know if that helped. If you have specific questions, you got to throw them at me. I think a few of you guys did. But I really want you to see it's not just guessing. It's not just, well, it's impossible to understand. There are generalizations you can make safely here, right?
I just want to make sure, you got 3 minus y by taking the square root and then leaving out the -3 because that doesn't fit in the right?
I'm sorry. Taking the square root of what?
9 minus y squared, what you got there.
9 minus y squared.
Okay.
Oh, for the R outer.
For our.
Oh, this has 0 to do with that. I am serious. This work has less than nothing to do with this work.
Oh, wait,
Because I could have put this axis anywhere.
and
It just was coincidental that it kind of looked like it was related to that, right?
Yeah.
Just because I picked an axis location that kind of went with that number. Totally coincidental. Okay, I like it. I don't know. Now, I understand that the correct answer to, if I ask you, how do you feel comfortable with discs and shells, should probably be not really, right? It's not straightforward, but it's a bunch of little tiny things. And if you, the more you're able to say to yourself, all I care about right now is which method. All I care about right now is what's R. All I care about, right? Instead of just thinking you have to worry about the whole thing. Yes?
Like you said, now you would FOIL it out.
Yeah, now I would FOIL it out, and right. I mean, I really hope you guys are cool with. I mean, we can do this. It's just right. So you get 6y plus 9 minus 3y squared minus 2y squared minus 3y plus y cubed. Get my like terms together. It's just a polynomial, so integration's easy. And then I plug my stuff in there, right?
Is that same idea of like, it's just little steps and for like related rates?
Of course.
Okay.
Yeah, because it's sort of like what I try to do. I try to point out the steps. Graph the shape. That helps you identify variables to describe the shape. That's where you pick the letters. Use those letters to summarize what they tell you, right? There's definite steps involved. And each step, you just focus on it, get it done. It builds into the next step, right? This is how almost all of math is. So the people that kind of naturally break things into parts will naturally be a little better at math. Sort of like, is anybody a good artist out there? I know at least one of us is, right? And you are able to do something I so desperately cannot, right? I absolutely am amazed when I see somebody draw an ellipse and then suddenly it's something, and I'm like, what the shit? So you're able to break things down into their basic shape elements, and that's how you build something, is that correct? And I cannot. I understand that's how you do it. It's just not natural. So if I wanted to be a good artist, I would have to really work at that. noticing the parts. Same thing with math, right? Not exactly. Same idea. Okay. I'm a good painter because it's a little more abstract. I can just go, oh, that was gonna be this, but now it's a rock. Yay! All right, maybe. So what's important there is, the specific thing is, do you know the integral form for any disc washer, right? Do you know the integral form for any shells? And then just the concept of how to determine which one. Now, could I ask you to use, just like I did on the last test, I said use discs. I wanted you to use discs. Because I think on that one you actually could have used shells. But I'm just going to give you one. I'm not going to tell you. You got to know which one to do.
Definition of derivative.
Ooh, yeah. So what is that referencing? The definition of derivative. Is that a bunch of words?
Derivative using limits.
Yeah, it's the limit definition. I love it. So give you an f of x, and then you take the limit. And again, this really is this, right? So again, it's y2 minus y1 over x2 minus x1. You see how that's the input there, that's the input there? It's just freaking algebra written in a funkier way. And of course these x's cancel, and that's why there's just an h on the line. Yeah, so I'm pretty much limited to a few. I can ask you to do, I can give you like 1 over x, or I can give you like x squared minus 2x or something. I can't give you like secant x. Because that would not be easy to figure out how to simplify this. But if it's polynomial, you can FOIL and cancel and kill the h, right? If it's this, you can get like denominators and do very similar things, right?
How do you find h?
Say again?
How do you find h again?
You don't find h.
Oh,
What do you
I
mean?
don't.
We want h to die.
Yeah.
And h is anything it wants to be as long as it's going to 0. Yeah. Is that all right?
Can you do a problem?
Sure. Give me a function.
Just going on the practice test, 3x squared minus 2x.
So what's f of x plus h?
3x plus h squared minus 2x plus h.
And what am I doing right now? I'm just doing the building. F of x. I need f of x. I got it. Check. F of x plus h. Check. Let me figure out f of x plus h is. I'm building what I need. Right. So just to cut to the chase, this would be 3x squared plus 2xh times 3 is plus 6xh plus h squared times 3, so plus 3h squared minus 2x minus 2h. No like terms, right? Is that all right? And then you build what you need. I fill in what I've built here. Limit h goes to 0. F of x plus h is this business. Minus. So one big mistake I see people make is they don't subtract the whole thing. 1 over h. So what tells you, especially with a polynomial, what tells you you're on the right track if I'm able to kill my h's? Because what's the problem here? It's freaking 0 over 0. So if I can kill this 0, then it becomes determinate. It's not over 0 anymore then. So it kind of makes sense. I want to kill the h. So just get my like terms together. 3x squared minus 3x squared cancels. Negative 2x minus negative 2x cancels. So then I can kill an h, kill an h, kill an h, fill in h, and then let h go to 0. There. And of course, the beautiful thing about this now is, what's the derivative of this? 6x minus 2. Hey, oh, hey, oh. Okay.
Can we evaluate someone?
Evaluate.
With limits?
Oh.
Yeah.
So you know I'm going to give you, let's see. All right. So what would you do there?
What is that, x squared minus 1?
Sorry.
I would probably seem like a factor and simplify, but I can't really.
You're skipping the most important step.
Oh, you just plug it in.
Plug it
There
in
is.
to see what you're working with.
Yeah,
Right?
it is.
So what do you get on top? Put a 2 in there.
8 minus 9.
And on the bottom, you're going to get 0, yes? So is that indeterminate? No. It's some kind of infinity, right? You just got to figure out what kind of infinity it is. And to be really honest, this one's a little bit evil. I have to give you something like that. Because what's on the bottom really is this, right? As x goes to 2 from above, that's positive. Right? That's 2 plus 2, 4. It's around positive 4. This, as I go from above 2, when I subtract 2, is it positive or negative?
It's negative.
If I'm coming from above 2, so if I put a number bigger than 2 and then subtract 2, I'm left with positive. So this would be negative infinity, right? Negative 1 over positive big. It's negative, positive small, I mean, negative infinity. All right, so that was a little worse than I wanted. So the first thing to do is just plug it in. I could have even put like a 5 there, and then it would have just been a number. I can see what that. So what if I gave you one? What if I made that 8? You do it 2 different ways now, right? You do it 2 different ways now, right? So which way? What do you want to do? So that would be using. He's rolling over his grave. L'Hopital's. So if I use L'Hopital's, because this is, again, you can only use L'Hopital's if what you have is what?
0 over 0 or infinity over infinity.
Some kind of ratio, some kind of indeterminate ratio. So in this case, I get 0 over 0. So L'Hopital's works. What's the derivative of the top? What's the derivative of the bottom? 2x. But doesn't an x cancel? And then can I just plug a 2 in? I'll get 6 over 2 is 3. All right, let's check that. What's the other way I could have done this? Factoring. Plug a 2 and I get 4 plus 4 plus 4 is 12. Divided by 2 plus 2 is 4. 12 divided by 4 is 3. Now, so sometimes you'll have an option, sometimes it'll be some gross shit that you want to do with derivatives, like a natural log in there or something, right? So you got to be really careful about the very first thing you do is it hard? If I plug the number in and it's not indeterminate, that means it's not hard. That means I can determine the answer immediately. If it's indeterminate, fudge. I've got a factor or a L'Hopital or something. Right?
So if it's not determinate, then we know for sure, then we can't factor and simplify, then we know it's going to infinity.
Oh, if it's not indeterminate?
Yeah, it's not indeterminate, and we can't simplify. It's going to infinity.
No, we don't know that. What do you mean it can't simplify?
Like you can't factor anything.
Oh, all right. Well, what if it was? All right. The thing is, if it's polynomials and it's indeterminate, it must be factorable. if a polynomial is 0, all right, this is an obscure pre-calculus thing. If I plug a number into a polynomial and it makes it 0, right? So if I have a polynomial, you guys should know this. Now let's say x equals 2 makes it 0. Doesn't there have to exist an x minus 2 factor in it? Yes? Okay. So if it's a polynomial and it goes to 0 at a certain value, whole number value, then I should be able to factor. Right? Okay. But if it's like a trig function or a natural logarithm, I can't factor those in the first place. Right? Then I'd probably use L'Hopital's if it's indeterminate. Right? Polynomials have a choice because they should be factorable in those cases, but I could just use L'Hopital's. Right? I know this feels possibly overwhelming, but again, you just go through, you just make sure you feel pretty good about each thing, right? Try to build up, if you feel really bad about this and good about that, and you focus on this. So, I mean, this kind of a outline kind of helps you focus on what you need to focus on. Yeah, and again, I would look at old practice tests, I would look at old tests, obviously homework, right? You could also look at the chapter reviews, because they have the answers for all the chapter reviews in the back. Yeah.
What's optimization referring to?
Anybody remember what optimization is? What does it mean to optimize something? Make it best, right? So if I want to optimize my profit, I want to make it the highest, the max. If I want to optimize my cost, make it mid, right? So that's the max and mid stuff. Find the derivative set equal to 0.
So optimization is just like another word for maximums.
Basically, yeah.
So the thing is, you have to set it up like really
Yeah,
great.
so it's a maximum problem where you have to create the function to work with in the first place. So that's the tell me, ask me stuff, and put it together. Yes?
What's the package fee?
Oh, mean value theorem.
Oh, okay.
Yeah, so look that bad boy up. Yeah, that didn't really come up too much, so I don't know if I'm gonna ask anything specifically about it, but.
Can you give us an example of optimization though?
Sure. 4-7. Here we go. I think, no. I guess I don't have it on here. That's funny, I didn't put an optimization problem on the thing, but that's fine. But it's like, it's the, find the largest rectangle that you're gonna describe in an ellipse. Remember those problems? You don't, so there was that problem about, it was a semicircle, I think it was on the test, find the largest rectangle inscribed in a semicircle.
Oh.
Right? I was like, try again, buddy. So, alright. So if I give you a circle, and let's say this is x squared plus y squared equals 9. And I want to know the biggest rectangle that can live in that semicircle. Well, the first thing is, that functionism given to me is not good enough, because that function would give me, it's not a function even, it would give me the bottom part. I just want the top part, right? So what can I do with this?
The square root, and then only
Yeah, I could
plus-
solve for y. And then I only have to do positive because I don't want I want the top. So this would be y equals square root of 9 minus x squared. Alright, so tell me what this is. I've already identified variables, so we know exactly what that is. X. And what's this?
Why?
Y. So what's the area? Right? So this is what they tell me. They told me I live in a semicircle. Under this. And they asked me to maximize the area. So I write what they tell me, and I'm going to write what they ask me. What is the area of this rectangle?
2x.
2xy. I love it. Right? It's the length times the width. 2xy. And of course, too many variables there. What can I replace? Yeah, does they know this? And then to figure out the maximum, I'm just gonna take derivative and set it equal to 0. I could also look where it's undefined, but most likely those places would make this area 0 or something. Is that's kind of like one of the types of, you also had to find the point on this that's closest to this point, right? Do you remember that? Here's a parabola, find the point on the parabola that's closest to this point. Kind of like a closest approach of a comet or something to our planet. Yeah.
Sorry.
That's all right.
We do
So, yeah.
like a concavity, a quick review of just the matches and everything.
What about it?
Concavity and finding maxes and minimums.
Oh. Like finding local max-min, finding deflection points.
Yeah.
All right, let's do that, and then we'll probably wrap up and pick it up again on Friday. But, I don't know how this is going to turn out, but let's find out. So say I want to figure out the intervals of increase, decrease, and the local maxes and mins. What would I do?
See immediately that one is a double root and two is a triple root, so.
Sure. And that doesn't do anything for me. It will help me when I have to graph this, because that'll be multiplicities, the roots, that'll help me when I try to graph this, but it doesn't tell me a damn thing about increase, decrease, extrema. So what do I do? You guys know. Yeah, because increase, decrease is slope, right? And extrema I find by seeing where the slope is 0. Those are the possible extrema locations. So what would the derivative of this be? Yeah, yeah, it'd be x minus 1 squared times the derivative of x plus 2 cubed, right? So the 3 comes down, x plus 2 to the second power. Is that pretty cool? That? Just the product rule. Not even a chain rule. I didn't make the inside gross, but I could. Now here's where people sort of, I love it when I give you what it's supposed to be and people have a miracle occur. And then it's all this blah, and then suddenly the answer's on. All right, no, come on. This is not hard. This isn't. And I'm not saying that to make you feel bad if you think it is. I'm saying that to make you realize this is not supposed to be challenging. This is just GCF. Do I see a number that I can take out? A number. 2 and 3. I can't take a number out. Do I see x minus 1s? How many x minus 1s can I take out? 1x minus 1. How many x plus 2 is going to take out? 2. I always try to move that over a little bit. So now this, the remainder is here. So what's left alive from this guy? 1x plus 2 is left over times 2, right? So it'll be 2x plus 4. Is that cool?
And then plus 3x minus 3.
Okay. Yeah, and then what's left alive over here will be a 3 times x minus 1, because I lost, yeah, so it'll be 3x minus 3. So then I get x minus 1, x plus 2 squared, 5x plus 1. So what are my critical numbers? And then I do my number line, right?
Yeah.
Figure out the pluses and the minuses. That's how I would do that. So if I put a 0 in, I get negative times positive, it's positive at 0. Right. And then I use multiplicity because I like to be nice to myself. So it's going to change signs around 1 because it's an odd multiplicity. It's going to change signs around negative 1/5 because that's an odd multiplicity. It's going to stay the same sign around negative 2 because that's an even multiplicity. Or you can just plug a number in from each region and you'll get the same answer. So what does this mean? Where is it decreasing? Infinity to negative 2. From negative 2 to negative 1/5. Are there any mins?
Yeah, there's negative 1/5.
Yeah, down, up. So min, negative 1/5, comma, whatever the shit that is. We could throw in negative 1/5, right? Where would I put negative 1/5 to finish this point?
At
The original, of course. That always tells me where I am.
When you say the interval, or like when it's decreasing, you would say negative infinity to negative 1/5, right?
No, definitely not, because what's it doing in negative 2?
Switching.
It's resting. It's
Oh,
not going
it's
down.
under revenue.
It's
Yeah.
at a little shelf, right? I was thinking about a roller coaster. Oh shit! Oh, we're going even higher. So you just were resting for a second and then.
Yeah.
So here's the other way. And then what's happening at 1? Max, of course, because it's going up and then coming down. Yes. So the max would be 1, 0. It's like, yeah. Right. And then the funny thing is, I do a second derivative and then I just redo everything we just did. Except now, the critical numbers might reference an inflection point. And the negatives mean concave down, and the positive means concave up. But it's all the same exact work. It's kind of nifty. All right, I think it's enough for today. So we'll pick up there on Friday. Round 2 of final exam review on Friday. I will have the updated grade sheet summary then. So if you turn in any corrections today, I can put it on there. And I'll include the extra information about what you need in the final for Friday's grade sheet summary. Coolness. All right, guys. And don't forget my office hours.